Okay, in this video we will explore the relationship between a function equation and its graph. And so one of the main things you need to keep in mind is that the behavior of the graph at a particular zero is going to depend on the multiplicity of the factor from whence it comes. All right, so if you have a single factor, the function just goes straight through that particular zero. If it's a double, then you're going to have a bounce at that zero. And if you have a triple, multiplicity 3, then you're going to have what's called an inflection, where it sort of curves its way in and then curves out in the opposite direction. Or you could think of it as sort of flattening out and then going through. Okay, so watch out for those things. So when I look at this function, I think a couple of things. But the main thing I think is, what are the zeros? I have a 0 here at -3. Now, a 0 at -3 is going to translate into a factor of x plus 3. Now, notice this is a bounce, and we decided that if we had a bounce, that's going to be when we have a multiplicity 2, a factor that is squared. So that's how I know this one will be squared. Then I see another 0 right here at 4. That's going to correspond to a factor of x minus 4. And this one just goes straight on through, so I'm not going to put any exponent on that. And now I see another factor here, another 0 at 8. So that's going to be x minus 8. And this is an inflection. See how it sort of flattens out and goes on through? So that one should be cubed. But one more thing we have to worry about is, do I need a negative sign here? Well, you see how both ends are pointing up. Okay? So there are three possibilities when you talk about end behavior. Either both ends are going to be pointing up like this, or both ends will be going down, or the left side will be down and the right side will be up, or the left side will be up and the right side will be down. These are the only four possible ways that end behavior can go. These two are for even functions, have one of these, and over here odd functions have one of these end behaviors. And these are the positive versions, and these are the negative versions. So with both ends pointing up, that's like this parabola here. So that means, by the way, this was an even function. And it's a positive, so I do not need a negative on this. So that was it for number 4. For number 5, we're going to go in the opposite direction. So I'm looking at this, and we need to sketch a graph of it. And we can talk about the zeros, right? So this -1, x minus 1, is going to translate into a 0 of positive 1. And this factor of x plus 3 is going to give us a 0 of negative 3. So here at positive 1, I'm going to have a 0. See how it's squared? That's going to be a bounce right there. I'm just going to put a little b to remind us that this will be a bounce. The -3 is right here, and because it's cubed, that is going to be an inflection. So I'm going to put an I right there. Let's keep in mind that'll be an inflection. Now, it would help to know which one of these 4 situations we're in. And for that, we need to know whether it's even or odd. Even or odd refers to the degree. I've got 2 of these and 3 of these. That means the degree is 5. That is odd. You see the negative sign in front, so I've got an odd. That is negative. So that tells me that my end behavior is going to be of this type. Okay, that means I have to start high and end low. So that's what I'm going to do. I'm going to start high, do an inflection, and then do a bounce. So if I start high over here, my inflection might look like this. Okay, but then now I need to curve around right away so I can do my bounce. Okay, so it's going to look something like this. Notice it starts high and ends low just like we predicted, and I have an inflection like we wanted from the +3, which gave us the -3, and we have a bounce at the 1, which came from x minus 1 squared. So there you go. That's how you do number 5.